What's up, YouTube? This is Greg here from GregsTutoringNYC at gmail.com. We're going to jump right in today. I'm doing a few snippets at a time of the grade 9 math examples that are on the latest SHSAT Handbook. So let's just jump into here. I don't have a lot of time today. Doing a lot of these early in the morning because I have other sessions going on. So let me make sure we're live. We seem live. And then we're going to jump right into some of the problems. So we did 1 through 6 already. Question number 7. Make sure the camera's right. Is what expression is equivalent to 6 to the minus 10 over 6 squared? All right. So we're going to have 6 to the minus 10 over 6 squared. There's a couple ways to solve this. All pretty much require that you understand how to do exponents. All right. So we can bring the 6 squared to the top, or we can bring the 6 to the 10 to the bottom. There's a couple ways to look at it. So this is the same as if you will, as 6 to the minus 10 divided by 6 squared. All right? And we know that when we get a fraction, this is really over 1, right? So we're going to get 6 to the minus 10 times 1 over 6 squared, which is how we get the original formula thing here, or whatever, right? So that's what's going on here. So as we did the other day where we had a base to an exponent and a base to another exponent, you do the base to the x plus y. Okay? So division, if you have a base to an x over a base to the y, you're going to get the base of the x minus y. Okay? So that's what we're going to do. We're just going to subtract the 2 of those there. So we're going to get 6 to the minus 10 minus 2. This is a plus 2. So we're going to get 6 to the minus 12. And that's our answer. But if you go look to the choices, that's none of the choices. Oh, wait, sorry, it's D. No, D is actually 6 to the positive 12. So a lot of kids are probably going to end up still sticking with D. B looks like it should be the wrong answer, right? But you should also know the rule that a base to a minus exponent is the same as 1 over the base to the positive exponent. So these are all identities and so on. That's why a lot of kids can, for instance, do this example. And I tell everybody, make sure you know your fundamentals. And they're like, yeah, that's easy, right? And they don't know, remember all the other rules or never understood them. So it's not enough to say, oh, question number 7 is easy. I agree so far, all these seem to be fairly easy to do. It's what else are they going to do on the test, as test writers, to throw at you? What tweaks and variations are they going to make to this? So far, a lot of the questions on the sample test, the sample questions, are really just testing your knowledge. And normally the SHSAT goes further than that. So these questions so far are kind of unfair in a way, because the questions are going to be harder than that. And by the way, even though this is about SHSAT 9, these could also be SHSAT 8 questions. Easy peasy, no question about it. All right? So be careful with stuff like that. So in any event, if we get b to the minus x here, so b to the minus 12, which is what we got, is equal to 1 over b to the 12, or in this case, 6. So then the answer is b, 1 over 6 to the 12. Okay? You can also go back to the original problem. Let me write it neater. 6 to the minus 10 over 6. So we know that this is 6 times 6, right? So if we do the division, we know we're doing 2 more 6's of it, and that's how we get to 12. Okay, another way to look at it is that if you have 6 to the minus 10 over 6 squared, I gave this here before, but this actually the reverse of that is true as well. So this is equal to 6 to the minus 10 over 1 times 1 over 6 squared. Okay, so 6 to the minus 10 is the same as 1 over 6 to the 10th times 1 over 6 squared. So now we're just doing denominator multiplication. And that's equal to 1 over 6 to the 10 times 6 squared, and that's equal to 1 over 6 to the 12th. There's a couple ways to do this. I normally like to say to do all your SHSAT math on paper, but this is easy enough to just look at it and go with 6 to the minus 10, the bottom 6 to the 2, minus 10 minus 2 is minus 12, 6 to the minus 12th, where is that? It's not there. It's got to be 1 over 6 to the 12th. And you can get that, okay? All right, let me make sure we're still live. Yeah, we seem to be. Okay, since it should already be on your screen, yeah, all of question number 9 is already on the screen. So let's just jump over to 9. And again, 9 is easy, or should be, and they're testing again. And by the way, if we go back to I thought there was another exponent question here. Well, there's another scientific notation question, which is number 1. There might be another exponent question after this, I can't remember. Anyway, question number 1 was a scientific notation question as well. So you might say these are too easy, but again, they're testing your knowledge of it. The examples here seem too easy, but again, on the real test, they're not going to be. So that's the misnomer here. The good advice is use the official stuff and make sure you understand it officially, because this is from the Department of Education. That's the good news. The bad news is that the real test is nothing like the actual practice test here. It's harder. It's on top of it, it's test day. People have anxiety, confusion, a lot of pressure, etc., etc., etc. Okay. All right. So let's look at what we have here. We have the diameter of biological cell A is 6 times 10 to the minus 7 meter. The diameter of biological cell B is 3 times 10 to the minus 8 meter. Which statement correctly compares the diameter of these two cells? Okay, so they made this kind of scientific looking by mentioning that it's the biological cell. It could have just been of a thingamajig. The diameter of a thingamajig is this, the diameter of another thingamajig is that. Okay, that's really all they're saying here. So that doesn't really matter, and who cares if it's a biological cell or a biological anything or cell anything. Just that there's an A and a B. The diameter of A is this, the diameter of B is that. Which statement correctly compares the two? So we're going to have 6 times 10 to the minus 7, that's A. And we're going to have 3 times 10 to the minus 8, that's B. My handwriting's bad, I am sorry. Okay, so they're just going to be comparing them. So A says the cell of A is twice of B. So certainly, if we split this in half and make this X and this part Y, certainly the X part of A is large, twice as large as the X part of B. Okay? But what about this part? We can't ignore that part. So the answer can't be A. And then what happens is some kids get confused and they're like, well, that's minus 7, that's minus 8. So if this was half and that's 10 less or whatever, then maybe it's B. But no, you have to consider these are multiples of 10s on the Y side here, right? This is the whole number part, and this is the factor of 10 part. Okay, it's not in the whole number part. Here, it's 10 to the 1, 10 to the 2 is 100, 10 to the minus 2 is 100th. So we're talking about the fractional decimal points parts here on this side. But we don't care, it's still factors of 10. Okay? So that's why B can't work. First of all, B is half of A on the X side, and it's a factor of 10 less on the Y side. So it can't be that. So now we get into C and D, where the X side is a factor of 2. So now we have to get which of this side is a factor of 10, because C and D both deal with 20. Okay? And by the way, I'm going to take a slight sidebar at the moment. In a lot of problems, both on the ELA section and in the math section, are broken down to say something like, if X, then Y. And then if X, then perhaps Z. All right? And then it might say something like, if not X, then Y. And then if not Y, or not X, then Z. And there's this duality where one half might be the same or the opposite, and the other side is something else, which is the same and the opposite as well. So that's part about what's going on here in question number 9. We can see the cell is 2 in the first 2, and the cell is 20 in the other 2. So there's some sort of yin-yang, they're going back and forth, where they're basically splitting the questions into 4 parts. 2 of the parts in each case are the same in each case. So that's what's going on in this kind of a problem. And it can be confusing sometimes to resolve that, because it becomes a logic problem, especially on how to solve it, and especially in the ELA section. But all parts either have to be true or false. Okay? So that's what we're up against here a little bit. And that's a common thing that happens, of course, all kinds of standardized testing like this. Remember again, this is not testing in your classroom. This is something else. So if this is a factor of 2, where A is greater, then we need to find on this side which is the factor of 10, because together they're going to be 20. All right? Well, which is higher here, or which is smaller, should we say? 10 to the minus 8 is smaller than 10 to the minus 7th. Right? If I have 10 to the minus 1, that's equal to 1 over 10. If I have 10 to the minus 2, that's 1 over 10 squared, or 100. So this is larger, and that's smaller. So the higher negative exponent is the smaller number. So that means this is a factor of 10 higher than that one. All right, so it's twice and a factor of 10. So this is 20. So A is 20 higher than B, right, which gives us C. And just to make sure we're reading it correctly, D just kind of says the same thing, but B is 20 times A. That's not true. All right? All right, so the answer here is C. All right, let's go to question number 8. Let's just make sure we're still alive. And this will be the last question I'm going to do. I'm going to have a short one today, I guess. Or it depends how long it takes me, because sometimes I wander on these. I like to over-explain these things to you guys. So we have a question: which table best represents a linear function? So I normally say I like to look at the figures first, but each choice here has a figure. So in this case, I did glance at it, but they're all the same, and the words are short enough, and they're trying to shoot for something. So I noticed two things leap out at me. So the first is it mentions a linear function. So it's looking for something that's going to model y equals mx plus b. So we had this also in a previous question, where something that dealt with a linear function, number 4. Okay, so you need to grok out of some of these what's going on here, because here we had to figure out the slope, and there may have even been another question here already. Or I've seen so many test problems this week that my mind's just a blur here. So somehow we need to involve either this formula or something in it. And normally when you're given an example like this is traditional. And by the way, this comes up in the integrated algebra exam as well, that you normally get traditionally in grade 9. Some kids take it in grade 7, and enough kids take it in grade 8 now. where this question actually literally comes up. Which of these represents a line? Which of these is a linear function? Which of these is a parabola? Okay, on the SHSAT, you're not going to be asked which is a parabola. All right, but this is about the extent of this kind of question for you. So this is a pattern question that you need to identify when it pops up. Okay, so normally a question that has those words, mentions linear, and shows these tables, it's normally asking you to get the slope. Okay? So m is equal to the slope, is equal to the rise over the run, is equal to the change in the y over the change in the x. And it could also be said as y2 minus y1 over x2 minus x1. Okay, so that's what we're shooting for here. Okay, so the second thing I notice is that it says which table best represents a linear function. If we go to the question there, that word best, that annoys me. Because do they want us to find something that literally is a linear function or comes close to being a linear function? So when you see questions like this, because you could find E, oh, E looks reasonable, it's kind of close to being a line. You know, the table doesn't represent a circle, the table doesn't represent the square, the table doesn't represent a parabola. It's kind of an arc line, you know, if we find that out. It's an arc line, and that's pretty close to being a line. Okay, that's not what they're asking us for. And we're talking about a straight line here, but not a curved line, right? When we deal with the y equals mx plus b stuff, which is only a function. Okay, and it's a function because the y can be f of x. F of x equals mx plus b. We can say it that way. Okay, so there's different forms and different symbolic representations we can present for some of this. Okay, that doesn't matter. It doesn't change this. And by the way, this could kind of really still also be a grade 8 SHSAT question, just a harder one. Grade 8's not really asking you to do this kind of a thing. But at the same note, this is not a super hard question. Now the problem with this question is that it's forcing you to go through every stupid table here. Okay, there's more efficient ways to do this and not. So what I'm going to do is I'm actually going to bring that up. Do I have a copy of that? Yes, I do here. I'm going to put it here so because my penmanship is so horrible. So what we need to do is find the slope between a point and another point. And if it's the same between points, then we have a linear function. So if this is A, and this is B, and this is C, we can compare A to B and A to C. We can also compare A to C and B to C. Okay, we can also compare A to B and B to C. As long as any of those slopes are the same, we're cool. All right? So without further ado, let's go for it. So we have 5 minus 3 is 2 over 3 minus 1. Okay, let me write that out. 5 minus 3 equals 2 over minus 3 minus 1. So that's minus 3 plus 1, and that's equal to minus 2. So we get a slope of minus 1. So it doesn't matter if we now choose between A and B and C, or A and C, or B and C, as long as we get it. So if we do this one, we're going to get 3 minus 1 over minus 1 minus 0. All right, so we get 2 over minus 1 is equal to minus 2. So if we did this correctly, because these two numbers are different, this is no good. All right, so now we're going to do it for the second one, F. So we're going to do 7 minus 4 over minus 2 minus 1, so that's plus 1. So we're going to get 3 over minus 1 equals minus 3. And I'm going to do it here. It doesn't matter which 2 points we take. If it's on a line, the slope should always be the same. So we're going to 4 minus 3 over minus 1 minus 0. We're going to get 1 over minus 1. So this kicks out. Okay, if I did it correctly. So here's the problem with this. if you goop up one of these and it turns out to be the answer, you have to go through it all twice, and your page is already messed up. All right. Let's see here what we got going on anyway. And so the next one, we have minus 17, minus 12, minus 12, so it's plus 12. And then we have minus 4, minus 3, which is that. So we get, what do we get? Minus 5 up here. And down here we get minus 1. So that gives us a slope of 5. And then down here we get minus 12, minus 8 over minus 3, minus 1. So we get minus 20 over minus 4, and that's equal to 5. So this seems like it checks out. Okay, so far the answer may be G. Okay, and that means this needs to kick out as well. So we get 3 minus 3 over minus 1 minus 0, so we get 0 over minus 1 equals 0, a slope of 0. Okay, and then here we get 3 minus 5 over 0 minus 2, and we see that's not 0, so this kicks out. All right, so our answer here should be G, and it is. Okay, so there's another couple of things we can talk about here. Let me see, because I printed out 2 pages of this. We could have done this a little simpler. So in the worst case, that's what you need to do. We notice that H, this is a function table. We have 2 answers that are the same here. So we know because of that, this is no good. If it's linear, for every x coordinate, there has to be a unique y coordinate. So we didn't even need to do a computation for H, because there can't be, for 2 different x's, the same y. All right, so that's just a no-go there. All right, so we could have simplified some of the computations, which is that if we know the slope is the same, means the answer is the answer, then it means as you go, if you're in something here, and let's say this is your line, at any point if we go over x, we must go over a certain y. And we can do that by multiples. So if we go over 2x, then we should be able to go over 2y, up to y. And the same on the other side. Okay, and the same if it was a negative slope. We can go backwards x, up y, right? And it could be over here. We're going backwards x, up y, down y, and so on. So however you call it, whatever x you're going over, it's just going to be a factor based on if you want this point, this point, this point. It's just this, that. So all we're really caring about is if the distance, in other words, if the slope equals the changes of the y's over x's, all we're looking for is to see if this ratio stays the same. That's all we're looking for, is to see if the ratio stays the same. All right? So if we come here to E, we're talking about, so we're trying to find consistency. So if this keeps changing by 2, right, then whatever changes here needs to be the same. So from here to here changed by 2, but from here to here changed by 1. That means the proportion's not the same. Okay, and I'm not trying to say this is 2 over 2. I'm just saying for every unit this changes, this would change the same amount of units across each coordinate point. Okay, but in this case, it's by a factor of 2. So whatever it happens to be, since this was 2, it should have been the same. So if the distance between here and here is 2, and here is 2, then the distance between this and this should stay the same. So here it changed by 2, but here it changed by 1. So right there, boom, no good. Okay, we have the distance here changes by 3, and the distance here changes by 1. So what we want to see is that on the other side, we have some sort of pattern similar to that. So this changes by 1 and this changes by 1. So that means the proportion can't be the same. The proportion, so it works on, in this example, the consistency was on the y side, and we want to see if x was consistent. Here the consistency is on the x side, and we want to see if y is consistent. It's not. Boom, no good. Okay? Let's switch to the h now. We just said before that it can't be true, but so the distance here is 0, the distance here is 2. Already we know we don't have a line because it's not even consistent on its own side. Well, let's double check that. So we have the distance here is 1, and the distance here is 2. So because this is a 0, we're screwed. All right, so boom, that doesn't work out. So that brings us back to here. So here the numbers are nastier for certain, but we have some consistency we can go on. The distance here is 1, right? And the distance here is 4. So what we need to show is that there's that kind of factor there. So the difference between here and here is 5. So it's 1 to 5. So 4 to 20, we should have a 20 here. And the distance between 12 and 8 is 20. Bingo, yada, booza, right? Booyah. So there we have 2 ways. So this way is tedious, and it's a little more error prone. But once we realize the what's happening mathematically, we can go and just do this. So this, we have a test here now. We have a test that's timed, and you need to pace it out. So I would suggest this technique to do that. All right? All right, that's what we're going to do today, guys. Hopefully everybody had a super duper swell, lovely time. And I'll do a part 4 maybe tomorrow morning. I have to see. I'll do another Q&A session probably this afternoon. And everybody have a great time. I encourage you guys to like and sub this. I'm doing more of these. It's going to be on other topics. I did some main idea ones the other day based on feedback from so many kids about the problems they run into with main idea. It's worth giving a look-see. There's a few dozen other ones on here already related to grade 9 SHSAT. And if you have any questions, please email me. Send me your questions. What I'm going to do most likely is gather up assorted grade 9 questions you guys have that stumped you, or you're not sure about, or you got it 90% and you want to talk about a tweak or something. Let's do a stream that way based on your guys' input. So email me your questions. Make sure they're legible so that I can just easy peasy pop them together. That way there's no work for me. This takes a lot of my time up already. I'm giving this to you guys for free. I normally charge my students privately, so this is something you need to consider as well. If you take a photo, make sure it's legible. And on that, peace out. SHSAT takers, have a great day, and I will see you guys soon.